Let's go ahead and practice solving some absolute value equations together. And for these particular set of practice problems, not only are we going to solve each of these absolute value equations, but we're also going to plot the solutions on a number line as well. For number one, we want to notice right away that the absolute value bars are alone to one side of the equation, so that means we can write two separate equations right from the beginning. If this wasn't isolated to one side at the beginning, you just have to make sure you rearrange some things so that it does before we can separate into two different equations. All right, so again, this x plus 7 is alone, so we're going to set up the equation x plus 7, and we're going to say that's equal to 15. That's one of our equations. For our second equation, what we're going to do is we're going to say x plus 7 again, the same thing that's inside the absolute value bars, but we're going to set it equal to negative 15 instead. Remember, there are two values that have an absolute value of 15, so we need to solve for both of them right now. For our first equation on the left, we're going to go ahead and take away 7 from both sides of the equation. That's the subtraction property of equality. If we go ahead and do that, those 7s are going to cancel out with each other, and we're going to find out that x is equal to 8. For the equation on the right, we can go ahead and take away 7 from both sides of the equation. And if we take away 7, then those 7 and negative 7s are going to cancel out with each other. And so we're just going to say that x is equal to, and negative 15 take away 7 is negative 22. These would be the two solutions for this absolute value equation. We first have x is equal to 8, and our second solution is that x is equal to negative 22. If you want to check this, you can take this 8 and plug it in right in this x over here. So 8 plus 7 is 15, and the absolute value of 15 is equal to 15. And then you can also take this negative 22 and substitute it in here. Negative 22 plus 7 is negative 15, and the absolute value of negative 15 does also equal positive 15. Now let's go ahead and plot our solutions on a number line. All right, so here we have a number line, and what we're going to do is go ahead and just plot 0 somewhere here a little bit to the right, just because we don't have as many numbers to the right we need to put. And then roughly speaking, we can go ahead and put an 8 over here to the right side, and a negative 22 would be a lot further into the negatives over here. So where would the two solutions be that would make this equation true? One of them is going to be positive 8, so go ahead and put a dot there, and one would be negative 22, just like that. These would be the only two numbers that would make this absolute value equation true. For number 2, we have the absolute value of x minus 13 is equal to 8. And now notice right away that these absolute value bars are indeed alone, so we can get started right away with writing two separate equations. Again, the first equation is just going to be x minus 13 is equal to 8, right? Just a regular 8 over there. And then our second equation is going to be the same x minus 13, but we're going to set it equal to negative 8 instead, because the absolute value of negative 8 is also positive 8. To solve the equation on the left, we can go ahead and add 13 to both sides using the addition property of equality. So we go ahead and add 13 to both sides, then we find out that x would be equal to 21, just because 8 plus 13 equals 21. To solve our equation on the right, what we're going to do is add 13 to both sides of the equation, since it says minus 13 in the equation. If we go ahead and add 13 to both sides, then we're going to get x is equal to positive 5. So one of our solutions is x is equal to 21, and our other solution here is x is equal to positive 5. Feel free to substitute these values back into the equation to make sure they work, but in this case, hopefully you can agree with me that they do. For putting these solutions on a number line, they're both positive, right? So we can go ahead and put 0 maybe somewhere over here. Maybe 5 is going to be to the right of that. I'll plot that over here. And just relatively speaking, maybe 21 would be a lot further down to the right. But we can go ahead and put 21's dot right on 21, and then we can go ahead and put 5's dot over on 5. So I know I'm not being super thorough with the number line, but just showing you that these dots just represent what numbers are the solutions to this equation. For number 3, we have the absolute value of 4x plus 7 is equal to 29. So once again, notice how these bars are alone on one side of the equation. That's super nice. So we can go ahead and start by writing equations right away. So our first equation that we can write is the absolute value of this 4x plus 7. If it's equal to 29, then we would find a solution, right? Because the absolute value of 29 is 29. But also keep in mind that the absolute value of negative 29 is also equal to 29. So we can set the 4x plus 7 equal to negative 29 and see what value for x makes that true as well. So for the equation on the left, let's take away 7 from both sides of the equation. If we go ahead and take away 7 and take away 7, we're going to get 4x is equal to 22. And then to get x completely alone, we need the coefficient to be 1. So let's divide both sides by 4 here, right? Now, if you divide both sides by 4, you can pause to think about this if you need to, but 22 divided by 4 is going to be 5.5, or 5.5 if you want to write a decimal, okay? That's going to be the one solution that would make this true. And for our second equation, we can take away 7 from both sides of the equation. If we take away 7 from both sides, what we're going to be left with is we're going to have 4x is equal to negative 36. Now, if we want 1x, let's go ahead and divide both sides by 4. 4 divided by 4 is going to be 1x, or just x. And then negative 36 divided by 4 is going to be negative 9. So one solution is going to be x is equal to 5.5. And the second solution is going to be x is equal to negative 9. Let's go ahead and graph these solutions. All right, so the only two numbers that work here are 5.5 and negative 9 for this equation. I'm going to put 0 a little bit towards the right since 5.5 isn't as far away from 0. It has a smaller absolute value. So I'm going to go ahead and put maybe a tick mark here and say that's going to be where 5.5 would be. It's to the right. And then negative 9 would be a lot further to the left here. So I can put negative 9 here. So 5.5 would be one of the solutions for this equation. And then negative 9 would be the other solution. Here's number 4. For number 4, we have the absolute value of this 3x minus 5 is equal to 7. So notice how this absolute value bar is already isolated again, so we can get started right away. So we have this 3x minus 5. The absolute value of that, we can either equal 7, that's one scenario, because the absolute value of 7 would equal 7, or we can say that this 3x minus 5 would equal negative 7, right? Just because the absolute value of negative 7 is also positive 7. To solve the equation on the left, let's add 5 to both sides. If we go ahead and do that, those negative 5 and positive 5 will cancel out, and we have 3x is equal to 12. And then to get the coefficient for x to be 1, we can go ahead and divide both sides by 3. If we divide both sides by 3, then x will equal 4. For the equation to the right, we can go ahead and start by adding 5 to both sides of the equation. If we add 5, then that minus 5 and plus 5 will cancel out with each other. We'll get 3x is equal to negative 2. That's negative 7 plus 5. Then to get x completely alone, we can go ahead and divide both sides by 3. So in this case, our solution is going to be x is equal to negative 2/3, right? So just a negative fraction. So one solution is x is equal to 4. And our second solution here is x is equal to negative 2/3. Now let's go ahead and plot these solutions. Looks like 4 is further away from 0 than negative 2/3, or has a greater absolute value. So I'm going to go ahead and put maybe 0 closer to the left side here. And I can put maybe a tick mark up here for positive 4. And a negative 2/3 would be a lot closer to 0. So I'm going to say that's going to be negative 2/3. Okay, so 4, I'm going to go ahead and put a dot right over on that value. And then for negative 2/3, I'm going to put a dot over here as well. All right, for number 5, we have our first absolute value equation where the absolute value symbol is not completely isolated on its own on one side. So notice here that we have a 3 that is also on the same side of it. And so we can't write our two equations yet. If you ever see this, make sure we get rid of anything that's outside those bars first. All right, so this is our original equation. And to get the absolute value bars isolated, what we're going to do first is divide both sides by 3. If we divide both sides by 3, then the 3's are going to cancel out with each other, right? And we're just going to be left with the absolute value of negative 5x plus 3, right? Now that's going to be by itself. And on the right side, 21 divided by 3, that's going to equal 7. So now that the absolute value bars are isolated, we can go ahead and write our two separate equations. The first one is going to be negative 5x plus 3, and that's going to be equal to 7. And our second equation is going to be negative 5x plus 3 is equal to negative 7. Okay, so now we're going to just solve this the way we've been solving the first few examples. We can start by subtracting 3 from both sides of the equation. If we go ahead and do that, then the 3 and the minus 3 will cancel out. They're going to be left with negative 5x is equal to 4. Then to get x completely alone, we can go ahead and divide both sides by negative 5 and negative 5. So we will end up with x equaling negative 4/5. All right, that would be one solution. For our second equation, let's go ahead and take away 3 from both sides of the equation. If we do that, then the 3 and the minus 3 will cancel out, and we're left with negative 5x is equal to negative 10. Then we can divide both sides by negative 5. If we do that, then x will equal positive 2. So you can see here we have two solutions. One is x is equal to negative 4/5. And our second solution here is that x is equal to positive 2. On a number line, let's go ahead and just put 0 over here. Maybe 2 would fall to the right, maybe by this much. And then negative 4/5 would be a little closer. We can put that as negative 4/5, but it's also pretty close to 0 there. So negative 4/5, go ahead and put a dot, and then positive 2, that's going to be over here to the right. For number 6, notice that we have a little bit more going on here. So we have our absolute value bar around this 9 minus 5x. Now, in order to write our two separate equations, we do have to get rid of this minus 7 first, and then we have to get rid of this 5. So here is our original equation, and we got to get rid of this minus 7 first, and we can do that by adding 7 to both sides of the equation. So if we go ahead and add 7 to both sides, we're going to be left with 5 times the absolute value of this 9 minus 5x. And then on the right side of the equation, 38 plus 7, that's going to equal 45. Now to get rid of this 5 we have in front, what we can do is divide the left side of the equation by 5, and then divide the right side of the equation by 5 too. So these two 5s will cancel out on the left side, and we're just going to be left with the absolute value of 9 minus 5x. And that whole thing is going to be equal to whatever 45 divided by 5 is, and that's 9. Now that we have the absolute value bars isolated, what we can do is write our two different equations. So one equation here is going to be 9 minus 5x, and that's going to equal 9. And our second equation here is going to be 9 minus 5x, and that equals negative 9. To solve these equations, what we're going to do on the left is let's go ahead and take away 9 from both sides. If we take away 9 on both sides, the 9 minus 9 will equal 0. We're left with negative 5x is equal 0. And then to get x alone, we can divide by negative 5 and divide by negative 5. So then we end up with 1x, or just x equaling 0. That's one of the solutions. For the second equation, let's go ahead and take away 9 from both sides as well. So we go ahead and do minus 9 minus 9. On the left side, the 9 minus 9 cancel out, and we're going to have negative 5x is equal to, and a negative 9 take away 9 is going to be negative 18. And then divide both sides by negative 5, and you're going to see that if we do that, then we're going to get 1x, or x is equal to, and then 18 divided by 5 is going to be 3 3/5, or 3.6 if you want to write it as a decimal. So one of our solutions here is x is equal to 0, and our second solution here is x is equal to positive 3 3/5. Putting this on a number line, just kind of squeezing this in here, we're going to have maybe 0 over here to the left, and then over to the right somewhere we're going to have 3 3/5. Okay, those would be the two values. And then since x equals 0, that would be one of the solutions. Go ahead and put a dot there, and then x equals 3 3/5, so we can go ahead and put a dot on that value. Alrighty, on to number 7. For number 7, right away we can see that we do have this absolute value bar on the left side, but then this 3 kind of needs to go, so let's go ahead and take care of that first. Alright, so first things first, let's go ahead and get rid of that 3 on the left side. We can do that by dividing both sides by 3. These 3's will cross cancel with each other, so we're going to be left with the absolute value of negative 5x plus 3. Okay, that's going to be on the left side, and on the right side, 21 divided by 3, that's going to equal 7. Now that we have these the absolute value bar isolated, we can write two equations. One is going to be negative 5x plus 3. That's going to equal 7. And our second equation is going to be negative 5x plus 3 is equal to negative 7. All right, to solve the equation on the left, let's take away 3 and take away 3. If we do that, then the 3 minus 3 will cancel out, and then we're left with negative 5x is equal to 4. And then if we divide both sides by negative 5, then we find out that 1x, or just x, is equal to negative 4/5. Okay, so that's one solution. For our second equation, let's take away 3 and take away 3 from both sides. If we do that, then 3 minus 3 will equal 0, so we have negative 5x is equal to negative 10. And then if we divide both sides by negative 5, just like this, we're going to find out that x is equal to positive 2. So one solution here is x equals negative 4/5. And the second solution is that x is equal to positive 2. Quickly on a graph here, if we go ahead and put 0 in this location, maybe something like 2 would be to the right, and negative 4/5 would be somewhere to the left, but a little closer to 0 because it's got a smaller absolute value. All right, so negative 4/5 would be somewhere like this, and then positive 2 would be somewhere over here to the right. All right, for number 8, we have 8 times this absolute value of 2x plus 4 is equal to negative 48. Now we see these bars, so we want to isolate it, so we have to get rid of this 8. All right, so here is the original equation, and to get rid of that 8, what we can do is divide both sides by 8. That way these 8s will cross cancel with each other. On the left side, if we do that, we will just be left with the absolute value of this 2x plus 4. And then that's going to be equal to negative 48 divided by 8 is negative 6. All right, at this point, notice something that is pretty interesting that's going on. If you're taking the absolute value of something, so on the left side, we're taking the absolute value, that distance always has to be positive. But if you notice over here that we have a negative value, that this is actually not possible, right? So in this case, make sure we go ahead and write a solution, and that for this particular equation, there's going to be no solution. All right, so if you ever isolate the equation, or rather you isolate the absolute value, and it's equal to a negative number, and you've checked all your work, then we would say that there's no solution because there's no possible way that we could get a negative distance. Okay, for number 9, let's go ahead and check out this one. This one looks like we got a little bit more going on. We need to go ahead and see if we can isolate this absolute value bar first though. 2 things we have to get rid of are this positive 2 and this negative 5. First things first, we're going to go ahead and subtract 2 from both sides of the equation. So if we go ahead and take away 2 from both sides, then 2 minus 2 is 0. We're going to be left with negative 5, and that's going to multiply by the absolute value of this 5x minus 5. Go ahead and put the second bar there. That's going to be equal to negative 73 minus 2. That's negative 75. So it looks like this might have no solution maybe for a moment, but keep in mind that we also have to divide both sides by negative 5. To get rid of that negative 5 in front. So negative 5 divided by negative 5 will cancel out. And on the left side, we're going to have the absolute value of 5x minus 5. And then on the right side, negative 75 divided by negative 5 is positive 15. So this equation actually will have solutions. Okay. Our first equation is going to be 5x minus 5 is equal to 15, because the absolute value of 15 is 15. And our second equation is going to be 5x minus 5 is equal to negative 15, because the absolute value of negative 15 is also positive 15. To solve the equation on the left, let's go ahead and add 5 to both sides first. If we do that, then we're going to be left with 5x is equal to 20. Then we can divide both sides by 5. If we do that, we find out that x is equal to 4. For our second equation, we could start by adding 5 to both sides of the equation, because that's the opposite of subtracting 5. If we do that, then we see that the minus 5 and plus 5 will cancel out. We're going to get 5x is equal to negative 10. And then we're going to divide both sides by 5 here, divide by 5. We're going to find out that x is equal to negative 2. So one of the solutions here is x is equal to 4. And our second solution here is x is equal to negative 2. Plotting these on a number line, maybe we'll go ahead and put 0 a little bit closer to the left side. That puts 4 a little bit further to the right, and then negative 2 a little closer but to the left side. So 4, we can plot a point right on top, and then negative 2, we can plot a point right over here. Let's look at number 10 now. So we can see where the absolute value bars are. We have 2 things to get rid of. One is going to be this 3, and one is going to be the invisible negative 1 that's kind of on the left side of that absolute value bar. All right, so first things first, let's go ahead and take away 3 from the left side and take away 3 from the right side. So we can get rid of that 3. So 3 minus 3 is 0. And so we're going to be left with negative, and then the absolute value, or the opposite of the absolute value, of 8x minus 6. Okay, so that's what's going to be left on the left side right now. And on the right side, 3 minus 3 is 0. Now again, there's an invisible negative 1 here. So what we can do is we can go ahead and divide both sides by negative 1 and divide by negative 1. Since negative 1 divided by negative 1 will cancel each other out, then we will just be left with the absolute value bar. So we'll have the absolute value of 8x minus 6, and that's going to be equal to 0 divided by negative 1, which is still 0. All right, so we can now write 2 different equations since the absolute value bar is isolated. So first, 8x minus 6 is equal to 0. That's one equation. And then we can say 8x minus 6 is also equal to 0, because the opposite of 0 is 0. So you can see here that it's actually redundant, and we technically don't need to write both of these. So we could just solve one of them, right? So don't feel like you have to do both. Next, we're going to go ahead and add 6 and add 6 to both sides of the equation. If we do that, then we're just going to be left with 8x is equal to 6. And then if we divide both sides by 8, then we're going to find out that x is going to be equal to 3/4. I'm going to just write it to the right over here so we have a little bit more space. This would be our one solution for this equation just because the absolute value of 0 is just equal to 0. So we only have one solution for this equation. Putting this on a number line, we can go ahead and say that maybe 0 is over here to the left and maybe 3/4 is over here to the right. But really there's only one solution here, so we can just put one dot on 3/4. That's the only number that makes this equation true. For number 11, we have an equation here that has a 6 in front, and then we have this -9 afterwards. So first we're going to have to add 9 to both sides, and then we're going to have to divide both sides by 6. All right, so here is our equation. Let's go ahead and see if we can get those absolute value bars alone. We can start by adding 9 to both sides. So if we go ahead and add 9 and add 9, we're going to get 6 times the absolute value of 1 minus 5x. And that is going to be equal to, because that -9 and +9 cancel out, 57 plus 9 is going to be 66 on the right side of the equation. Next, we want to get rid of this 6, so we can go ahead and divide both sides by 6. On the left side, these 6's are going to cross cancel with each other, so we're going to get the absolute value of 1 minus 5x. That's going to be on the left side, and on the right side, 66 divided by 6 is equal to 11. So we can now write two separate equations. So we can say 1 minus 5x is equal to 11. And for our second equation, we can say 1 minus 5x is equal to negative 11. All right, so those are our two equations. For the one on the left, let's solve it by taking away 1 from both sides first. 1 minus 1 on the left is going to be 0. So we're going to have negative 5x is equal to 10. And then we're going to go ahead and divide both sides by negative 5. And if we do that, we find that x is equal to negative 2. For the equation on the right, we're also going to take away 1 from both sides first. If we go ahead and do that, then 1 minus 1 is 0, just like we just did. So we have negative 5x is equal to negative 12. That's negative 1 take away, or negative 11 take away 1. And then if we divide both sides by negative 5, then a negative divided by negative is a positive. So we're going to get x is equal to 2 2/5, or 2.4 if you want a decimal. So here's one solution, x equals negative 2. And for our other solution, we can say x equals 2 2/5. For our solutions here, we can go ahead and put maybe 0 in this location, and then that would leave negative 2 over here to the left, and that would put our 2 2/5 over here to the right, just like this. And so we can go ahead and put negative 2, put a dot there, and then put a dot on 2 2/5. For number 12, this equation's got a lot going on again, so notice where the absolute value bars are. Let's go ahead and take care of this -7 and 5 before we can split into two different equations. All right, so to get rid of this -7, let's start by adding 7 to both sides of the equation. If we add 7 to both sides here, then we're going to be left with 5 times the absolute value of 9 minus 5x. Let's go ahead and put those bars around this. 7 and the negative 7 cancel out, and on the right side, 38 plus 7 is 45. Next, to get rid of the 5, let's go ahead and divide both sides by 5. And if we divide both sides by 5, then these 5's are going to cross cancel with each other, so we're left with the absolute value of 9 minus 5x. And then on the right side, 45 divided by 5 is going to equal positive 9. At this point, we can split the two different equations and say 9 minus 5x is equal to positive 9. And for our second equation, we can say 9 minus 5x is equal to negative 9. All right, so to solve this, we can start by subtracting 9 from both sides of the equation. So 9 minus 9 on the left side is going to be 0, so that's just going to be negative 5x is equal to 0. Then to isolate the x, we can just go ahead and divide both sides by negative 5. The negative 5's will cancel out, and 0 divided by negative 5 is 0, so x equals 0 would be one of our solutions. Okay. For our second equation, we can take away 9 from both sides as well. If we go ahead and do that, then on the left side, 9 minus 9 would be 0, and so we're just left with negative 5x equals, and a negative 9 minus 9 is negative 18. And then finally, let's divide both sides by negative 5 so that we can get x alone, or 1x. And so we get x is equal to, and then negative 18 divided by negative 5 is positive 3 3/5, or you can say 3.6 if you like decimals more. So here's one of our solutions, x equals 0, and our second solution of x equals 3 3/5. And looking at one more on a number line here, if we go ahead and put 0 over here to the left, and then put 3 3/5 over here to the right, those are actually our two solutions, so we can go ahead and put a dot on 0. If x was 0, this equation would be true, and if x was 3 3/5, this equation would also be true. All right, so there you have 12 different practice problems on solving some absolute value equations. I hope you found it helpful. If you did, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.